question says that the function fx equals 4 minus 3 sine x is defined for the domain 0 to 2 pi. Okay. In part 1, we have to solve fx is equals to 2. Okay. So 4 minus 3 sine x is equals to 2. That gives us 2 is equals to 3 sine x. 2 upon 3 is equals to sine x. And the domain is from 0 to 2 pi. We take sine inverse. This gives us the absolute angle, which comes out to be, remember to set the calculator in radians. Okay, this gives 0.7297. So in three significant figures, I can write it as 0.730. Okay, now sine is positive in the first quadrant and in the second quadrant. So the solutions in the interval should be this one and this one. So one of the solution is simply 0.73 and the other one would be pi minus 0.73, which comes out to be pi minus answer 2.41. These are the two solutions of the equation in part 1. Okay. Next, we have to sketch the graph of fx. Okay, let's do that. Here's the x-axis, the y-axis. The domain is from 0 to 2 pi. Okay, and the central line is 4. So 1, 2, 3, 4. The highest value is going to be 3 above 4, so 5, 6, 7. This will be the highest value that the graph can take. And the lowest value would be 3 units below 4. That's going to be 1. Okay, I'm going to project these here. Okay, now I'm going to draw the graph of minus sine x within this region, because and minus sine x is going to be an upside down sine graph. So I get something like this. The dotted lines help in getting a symmetrical graph. Okay, and now I'm going to get rid of these dotted lines. They're not needed. Okay, so here's the graph of the given function within the given domain. Okay. Part 2 is done. Part 3 says, find the set of values of k for which the equation fx equals to k has no solution. Okay, fx is equals to k means y is equals to k. And y is equals to a constant means a horizontal line. Like y is equals to 7 would mean this line. Y is equals to 4 would mean this line. Y is equals to 1 would mean this line. Now, each of these lines have certain number of points of intersection or solutions. So this one, the first one has 2 points of intersection or 2 solutions. This one has 2. This one has 1. Okay, now we need such a horizontal line that does not intersect with the graph so that we get no solution. Okay. That is, just give me a second. All right. So, yes, back to the question. It says that find the set of values of k for which fx equals to k has no solution. Now, if you draw a line, any line above 7, then it won't intersect with the graph. Or if you draw any line below 1 here, then it won't intersect with the graph as well. So if k is greater than 7 or if k is less than 1, then you will not get any solution. Otherwise, if you draw any horizontal line between 1 and 7, you will definitely get some points of intersection or solutions. So the answer is k is greater than 7 and k is less than 1. Okay. Okay, next it says this was 0. Okay. State the function gx equals 4 minus 3 sine x, it's actually the same function, so the same graph is applicable on it, is defined for the domain pi by 2 to a. So the graph starts from here, and we don't know what a is, it goes till a. State the largest value of a for which g has an inverse. Okay, that's going to be from here to here, because only in this region you get a one-to-one function, because if you draw a horizontal line test in this region, then it only cuts the graph at one point. Otherwise, if the graph is even slightly bent beyond this, then the horizontal line test fails and you cannot find an inverse. So you have to end the graph there. So the maximum value that a can take is 3 pi by 2. So for part 4, the answer is 3 pi by 2. The last part says that for this value of a, find g inverse of 3. Okay. So g inverse of 3 is going to be, first let's find g inverse of x. So I'm going to write y equals 4 minus 3 sine x. Okay, 3 sine x equals 4 minus y, and 3 gets divided, and we take sine inverse, or g inverse x equals sine inverse 4 minus x upon 3. Now we have to find g inverse of 3, which would uh, be sine inverse 4 minus 3 upon 3, which gives sine inverse 1 over 3, 0.3398. Okay, now this is going to be a problem. This does not lie within this given domain. What was our domain from pi by 2 to 3 pi by 2? Okay, let me clear this. Okay, so what is pi by 2 in decimals? The domain is pi by 2 to 3 pi by 2. Pi by 2 in decimals is 1.57, and 3 pi by 2 in decimals is 4.71. So our answer should lie between this region. How do we make the answer lie within this region? Okay, we got a positive value of sine. Sine is actually, sine theta is equals to 3, which is a positive value. So if I plot this angle, this is in a way our absolute value. So sine is positive here and sine is positive here. The angle we got is this angle from sine inverse 1 over 3. I'm sorry, I meant 1 over 3. This 1 over 3 is a positive value. So we'll have 0.3398 in the first quadrant and 0.3398 in the second quadrant as well. So if we find this value instead, that should lie within the given domain. So if we do pi minus 0.3398, that gives us pi minus 0.3398. We get 2.80, which is within the given domain. So this is the correct answer. Now, if you try adding 2 pi to it, which is the period of sine, then you get 9.08, which goes out of the domain. So this is the only correct answer, 2.80.